Now in this module I'm going to discuss electricity. I'm going to take it back to the basic principles and then expand to be able to determine its parameters. Now to be able to explain electricity, I firstly need to explain the makeup of an atom. Now as you can see here, an atom is made up of a nucleus, which is the central core of the atom, and this nucleus is surrounded by a number of electrons which travel around it. Now these electrons have a single negative charge. In every nucleus there will be an equal number of protons which have a positive charge, thus making the atom neutral. Now there are also neutrons which do not have any charge at all. Now in some atoms these electrons can be easily detached, so in effect what you have is a cloud of electrons moving around the structure itself. So they're actually detached, but it's like a cloud of electrons. What you find is that because they're moving randomly, equal number of electrons moving in each direction, and so their effects will cancel out. Now materials that possess this quality are known as conductors and have a good example of these are metals. They have this cloud ability. Now what would happen if you placed a power supply to the ends of a conductor such as a battery? Well, what you find is that electrons will move away from the negative end towards the positive end, and this is because, as you can see here, at the negative end you have in effect a number of electrons available, and at the positive end there is a lack of electrons. Now it's very important that you understand that the second you connect the battery, electrons will move from one end to the other, but these are initially the electrons in the conductor itself to start with, because there's electrons in the conductor itself. Don't forget, in the wire itself there are millions and millions of electrons orbiting the atoms in the actual conductor itself. The best way to describe this is by using an analogy. I want you to consider a conductor as a pipe that water can travel through. Now if you put a pump in the circuit, it's like attaching a battery to a conductor. Now when the pump is started up, the water will flow in the pipe. Now I want you to consider that the pipe is already filled with water when you start the pump up. That's what I want the analogy to understand, that when you've actually attached the pump, the pipe is already filled with water, and what happens is the water starts to move, but initially it's the water in the pipe itself. Some was already there. This analogy of water flowing is similar to electricity, and it's going to be applied later. Now this movement of electrons is called an electric current, and materials which have electrons which can easily be detached are called conductors, such as metals for example. So we know what electric current is. It is the movement of electrons through a conductor. Now electric current is measured by the ampere or the amp, and it's the rate of flow of electrons. Now, how do you get these electrons to flow? Well, in the same way as you get water to flow, you've got to provide a potential pressure at one end, and this is known as electric potential. Now, it's very important that you understand that the potential difference across the ends of a conductor is directly proportional to the current flowing through it. So if you double the potential difference or the voltage, you will double the current flowing through it. So as you can see here, if the voltage is 6 volts and the current is 3 amps, if you connect another battery and double the voltage to 12 volts, then the current will increase to 6 amps. Now you also have to realise another important issue with regards to electrical potential, and that is, as you can see here, this is a 6 volt battery in a circuit here, as you can see. What this effectively means is that one end of these ends here has got 6 volts more potential energy than the other side, yeah? Now, if there was no resistance in the wire at all, there would be a high current flowing from one side to the other. Now, nearly all conductors have some resistance to the flow of electricity, albeit generally quite a low resistance. Now, the electrical resistance of an electrical conductor is the opposition to the passage of an electric current through that conductor. Now the opposite to resistance is electrical conductance, and the ease at which an electric current passes, that's what electrical conductance is. Now electrical resistance shares some conceptual parallels with the notion of friction. For example, friction as water flows down a hose. As water flows down a hose, it creates friction, and it's the same with electrical current going through a wire. So Now, the SI unit, the Systems International Unit of electrical resistance, is the ohm. And this is the symbol here, this is the ohm. While electrical conductance is measured in Siemens, and that is the conductance S there. Now, an object of uniform cross-section has a resistance proportional to its resistivity and its length, and it's actually inversely proportional to its cross-sectional area. So if you double the cross-sectional area, you have the resistance.